Alright, hi, I'm Zach,
And I'm Dan.
and we're going to teach you how to solve a basic tension problem. Now, in these tension problems, we have most likely two cables being hung by a mass, M in this case. This mass is usually given in pounds, and then therefore the forces will be in pounds. We're going to solve for the tension in cable A and cable B in this scenario. Now, we can't really solve it without breaking it up into its x and y components. So therefore, we're going to draw right triangles here, and then we will assign each side a force. And now, either in these problems, either we will be given lengths, and then we can use basic trigonometry to solve for angles, or we'll be given the angles just in the problem. In this case, we're going to pretend that we're given two angles, theta and phi.
So what you have to do to get the components is, again, basic trig. It's just going to be a times the cosine of theta to get the x component on this side, and then a times the sine of theta on this side to get that component. And then you'll do the same thing for b. So it's going to be b cos theta, or cos phi on that side.
Oh, sorry, it's supposed to be sine.
Yep.
Yeah, and it's cosine and sine because x just goes with cosine and sine goes with y.
It's just, yeah.
That's just how it works.
This side you're going to get b cos phi, and then for the y component you'll have b sine phi. So in these kind of problems, this weight is not moving, which means these two things have to be, the two x components are going to have to be pulling in the same amount, which means a cos theta is going to have to be equal to b cos phi. So this is also going to be, like I said, not moving. So it's got to be supported only by the y components. That means that this side, a sine theta plus b sine phi, are going to have to equal m.
B sine. Yeah, it's going to have to equal the mass. And then we would use, since we would know our value m, and we would know the two angles from either trig from the lengths or they'd be given, we would solve for the two variables a and b using systems of equations. And now we're going to do an example for you. So for this problem, we have the same kind of thing, two cables a and b, a little different angles now. This, if you remember, is a cos of theta, which is 24.3 in this case. And then this would be a sine 24.3 degrees. And now for this side, the same kind of thing. This time it's b cos of what we called phi before, which is now 44.5 degrees. And then the y component is b sine 44.5 degrees. Okay, so now if we remember correctly, these two equaled each other. So we can set them equal to each other, and we're using a system of equations. So, yeah. So we have a cos 24.3 equals b cos 44.5. So now if we're solving for just a in this case, we would divide by the cosine of 24.3. Cosine 24.3. And then a, with some basic calculations, would equal 0.783b.
So now what you have to do, like we said, you can keep going. 'Cause it's good. Yeah. We're gonna have to add a sine of 24.3 degrees plus b sine of 44.5 degrees, which should equal 2240.
Okay, so we get a sine 24.3 degrees plus our other y value, b, what Dan just said, sine 44.5 degrees, equals the weight of the mass, m, which is now 20,240 pounds. Okay, so now we know our value for a over here. So now we can plug that in here, just the basic systems of equations. So 0.7 83b times sine of 24.3 degrees plus b times sine 44.5 degrees equals 20,240. Okay, so now with some other basic calculations, we find out that this is 0.323b, and those multiplied by each other, because, yep. And we find the sine of 44.5, which is 0.701 times b, equals 20,240 pounds. So now we can add these, because they're both of the same variable, and we get 1.024b equals 20,240. We divide by 1.024. And we can solve that b is equal to 19,765.625 pounds. Now,
So for this one, again, you just plug it back in. So it's going to be, I guess we'll do this. A is going to be equal to this times your B value.
When
and
the
it's going to come
Merrill,
out to
dial
be
extension 3788.
7. That is the wrong one.
sorry about that. 19,765.
Is UB.
Yep.
So,
Times.
yeah. Okay. 19,765.625.
Yep.
Times
B value.
0.783. Wow, that's beautiful. 83, which is going to equal
15,476.4 pounds.
pounds.
So now if we look back at our diagram, this actually makes sense, because if you think about it, if you're holding an object, the more tension is usually on the steeper angle. So our B, we ended up with 19,000, which is more than A, and they're both less than this because some of the weight is lost in
The X direction.
the X direction. Yep.
Alright.
All right. If you go back to our original equations that we started with, A cos 24.3 equals B cos 44.5, and A sine 24.3 plus B sine 44.5 equals 20,240. We can plug in our A and B values, and the equations should equal each other. So if we'll start with the one in the X direction, which equaled each other. A cos 24.3 equals B cos 44.5. Our A value was 15,476.4, and then times the cosine of 24.3,
Which is 0.911.
0.911, equals our B value, which was 19,765, 765.625, times the cosine of 44.5, which is
0.713.
713. Now, after doing these calculations out, we find that 15,476.4 times 0.911 equals
14,105.
5. And then 19,765.625 times 0.713 equals.
14,097.
Now, they're not exactly equal because. Yep.
Nice.
These aren't exactly equal because of rounding error. We didn't store the values in our calculator, but you can kind of see the point that they do equal each other around the same kind of value. Yeah, you want to do
Yeah. So to prove the second half, we have to show that A sine of 24.3 plus B sine of 44.5 are going to equal our original 20,240.
So just bringing this equation down, we can take our A value, which is 15,476.4, multiply that by sine of 24.3, add B, our B value is here given from our calculations, 19,765.625 times the sine of 4.5 equals that. So after doing all these, we will calculate that this comes to be
6,368.8,
okay, and then we're going to add this times this.
which is going to be 13,853.9.
Equal, and that should equal to that 20,240. So now after Dan's calculations,
We get 20,222. 23.
is around 20,240. Now again, as we said before, there will be some error because we used rounded values. But as you can see, that's pretty much it.
Yep.
That's the tension, and then yeah. Thanks for watching.